So here we have some more common formulas that are the literal equations because there's more than one variable. So temperature, you can convert between degrees Fahrenheit and degrees Celsius. Simple interest is one of the examples that we will go through. Compound interest, and you've talked about both of those in all of your algebra classes in the past. And as you can see, the variables are defined here. So the I in simple interest is your interest. The P is the principal, which is your original amount. The R is the rate, and we need to write that as a decimal when we use our equation, and then T is time. So all of the definitions, and then same thing is true. Everything is given for your compound interest. And then distance, this is probably something you'd use more in science classes, but distance equals rate times time. And then just a note before we keep going, when you are working with these, it's often helpful to rewrite literal equations in terms of a different variable. So it's like you're given that one equation, but you want to solve for a different variable. And you can use just your properties of algebra to do that. So here we have the formula for perimeter of a rectangle. So here it's written as P equals, and here we have it as W equals. So what we would do to get there is we would take this equation and we would solve for W. So to solve for W, the first thing I would do is move the L value over, so subtract 2L, and then we would just write that as P minus 2L because those are different variables, and then I would divide by 2. Now, once you get to this point, there's different forms that you can write your answer, and you can leave it exactly like this, P minus 2L divided by 2. You could write it like they have it here with the 1/2 pulled out front, because that would be like taking your 2 from your denominator and writing it as a fraction instead. So this would be like 1/2 and then P minus 2L. That's the way they have it. So there's multiple ways of writing equivalent statements when you have multiple pieces like this. So when you do have your literal equations, it's really helpful to know how to solve for different variables. All right, so next here we have our mixture problem. So problems that involve 2 or more rates are called mixture problems. So for ours, we're going to use percents of simple interest. Different rates could be speeds like miles per hour, or it could be ratios, like if you're mixing water with powder to make lemonade. Like maybe you put 2 scoops for every 1 cup of water, but then you want to make 10 cups of water. So just kind of figuring all of that out. So there's different ways to do mixture problems. We are going to work with simple interest. So first, simple interest is one of our equations that was given to us. So it is I equals PRT, where I is the interest, P is the original amount that you put in, or the principal, R is the rate, and T is the time. So we're going to use this formula in this mixture problem here. All right, so let's go ahead and read through it. You invested a total of $10,000 at 4.5% and 5.5% simple interest. During 1 year, so there's our time, the two accounts earned $508.75. So this, when they earn it, they're talking about the interest. How much did you invest in each account? Okay. So we have 2 accounts. We have one account that is 4.5% and one account that is 5.5%. Right now, we don't know how much went into each one individually, but we know that there's a total of $10,000 between the 2. So what we can do is we can assign some variables. We have 2 different things going on here. So let's say that we use the variable x, and x is going to represent the amount invested at 4.5%. Okay. And then y is going to be the amount invested at 5.5%. Okay. Well, we know the total between the 2 is $10,000. We just don't know where that 10,000 gets split. So what we can do is we can say, well, the amount invested at 4.5% is X. So let's keep our X. And then let's try and write Y in terms of X. So instead of writing Y here, we can say that this is the same as if I started at 10,000, oops, and I subtract the amount that we invested at 4.5%, which is X, that's the amount that's invested at 5.5%. That's the difference. So we can create two expressions in terms of X. So now we have our 4.5%, do some different colors here. Our 4.5% is X, and our 5.5% is 10,000 minus X. So those are both now in terms of X, which makes our equation nicer and easier to solve. So going to the model that they have, we were given the total interest of $508.75. So our total interest was 508.75. In order to get that, we add the two interests together. Well, we need to know what the simple interest formula is, and we know that. We know it's I equals PRT. So we can take our verbal model here, and I'm going to translate it down. So interest from 4.5%. So PRT of 4.5%. I'm just going to write it out a little bit differently, plus PRT of 5.5% equals $508.75. So now let's substitute in. So the principal of 4.5%, that is our X value up here. We said X was going to represent the amount invested at 4.5%. So our P value for 4.5%, we're going to use X. Okay. Our rate there is 4.5%, but remember, we need to convert that to a decimal when we use our equation. So if we move our decimal over twice, this would be 0.045. Make sure you're converting your decimals carefully. And then for time we said at the beginning here that the time was just during 1 year. So our time is simply 1. So there's our PRT, our simple interest for our 4.5%. Now let's do the same thing for our 5.5. So we said our 5.5% amount was going to be this 10,000 minus X. So here we'd have 10,000 minus X. This rate is 5.5%, so 0.055, and our time again is 1. And we can keep that equal to $508.75. So now we have an equation that only has X in it, we only have one variable, and we can go ahead and solve. So the most important part on all of these is setting up your equations, because I know you can solve them from there. So if we do that here, we would get 0.045x plus, and then here we would have to distribute. So 1, 2, 3, 4 zeros. So this would be 550 minus 0.055x, and then just times 1, so that doesn't change anything, equals 508.75. Combine our x values, simplify over, so I'm going to subtract this 550 here. Now that's going to result in a negative value over on my right side, but that's okay, because when we combine our x values, because we're subtracting this 0.055, that's also going to be negative. So that'll work each other out there. So if we combine our x values, we get negative 0.01x. And then if we combine over on the right side here, we get negative 41.25. And then if we divide to finish solving by negative 0.01, our x value gives us $4,125. So remember, our x value was the amount invested at 45%. So this is our amount at 4.5%. So then to find our other value, our y value, we said that y was going to be 10,000 minus whatever x is. So that would be 10,000 minus 4,125. So our y value here would be $5,875, and that is our amount at 5.5%.